Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 21st March 2023. The problem statement for today is taxi booking. This problem is based on array and greedy approach. Let's now open the problem to solve it. Let's go through and understand the given problem statement. Given problem statement says you are going to book a taxi. There are infinite number of points 1, 2, 3 and so on the x-axis, and your current position is current. There are n taxis near you and the position of those taxis is given in the array position, where position of I denotes the position of the ith taxi. You are also given an array time where time of I denotes the time taken by the ith taxi to cover 1 unit of distance. Your task is to find minimum time to board a taxi. Okay, so this problem says that you need to book a taxi and you are currently at the position current, which is on the x-axis. Suppose this one, this way it is representing. So currently we are at some point where we need to board a taxi, and there are n number of taxis near us. Okay, so we have to find the minimum time to board the taxi, and we have been given the position of all the taxis, and along with that the time for the taxi to cover 1 unit of distance to reach to our location. Suppose we are at location ABC, so the taxi at some other location has to reach this point which is called ABC, something like that, and to cover that distance 1 unit it takes some time. So that is represented in time array, and each time is again given by time of I hope this problem statement is clear. So let's go through the first example here. So here it is said n is equal to 3 and the current position of us is, that means current position of the person who is going to book the taxi is 4. So and the position of the taxis are 1, 5 and 6, and the time taken by all these taxis is given in the time array, which is 2, 3 and 1. This means for the first taxi to cover 1 unit of distance it take 2 unit. For second taxi which is at position 5 to cover 1 unit it takes 3 unit, and for the taxi which is at position 6 to cover 1 unit of distance it takes 1 unit of time. So here it is said the output is 2. Let's see how we have got the minimum time to board the taxi. So the total time taken by the first taxi will be 4 minus 1 into 2 is equal to 6. So whatever is actually that taxi has to reach our location. Okay, so the taxi has to travel from 1 to 4, from their position to our position. So the difference between these two, our current position and the position of all the taxis, so that difference into the time taken to cover each distance, that means each unit of distance, that is 2, that is 6 here. Similarly for the second taxi, from 5 to reach 4 into distance time taken to cover the unit distance, so that we are getting 3. So total time taken by the third taxi will be from their position that was 6 to reach 4 into 1, because for covering 1 unit of distance it takes only 1 unit of time. So that's why we have got 2 here. So the minimum time taken will be 2. So let's understand it with this one. So suppose we are at this position current at 4th position with this example only. So first taxi is here at T1, second taxi is here at T2, and third taxi is here at T3. So it will be for taxi 1 to come to our current position. So taxi 1 has to cover 1, 2 and 3 unit of distance. So that the same thing it has been done here. 4 minus 1 is equal to 3. It has to cover 3 unit, and for covering each unit it takes 2 seconds. That means 2 unit of time. For the fifth taxi, it is just on the position next to us, so it has to cover only 1 unit of distance, and for covering 1 unit of distance it takes 3 unit. And for the taxi 3, it is at position 6, so it has to come to 4, so it has to cover 2 unit of distance, 1 and 2. So and it takes 1 second or 1 unit of time to cover 1 unit of distance. So that's why we get here 6 minus 4, that is here 6 minus 4 into 1, that is 2 into 1, that is 2. So the minimum time will be 2 seconds. And let's go through the second example. Here it is giving that as number of taxis is 2 and our current position is at 1. So position 1 and 6 is the position of the taxis, and the time taken by them to reach to current position of 1, that is 10 seconds and 3 seconds. So it is like the previous example. It is also to cover 1 unit of distance, it takes 10 seconds for the first taxi, and for the second taxi it takes 3 seconds. But if you can see the explanation here, the output is 0. The total time taken by the first taxi will be 1 minus 1, that is 0. 0 into 10 is equal to 0. Because we are also at position 1, taxi is also at position 1. So taxi doesn't has to cover any distance. That's why it is taken 1 minus 1 is equal to 0. So we will be easily boarding the taxi as soon as we reach the current position. The time taken by the second taxi will be 6 minus 1, because the second taxi is at 6th position. To come to 1, it has to cover 5 unit of distance, and for covering each unit of distance it requires 3 seconds. So it will be total 15 seconds. So the minimum is 0 seconds. I hope this is in both these examples and this problem statement is clear. So the problem here is asked to find the minimum time required to board a taxi from the passenger's current position. To solve this problem, we need to iterate over all the taxis and calculate the time taken by each taxi to reach the current position. We can then take the minimum of all the times calculated to get the minimum time required to board a taxi. That's it. We have to do only this much in this problem. So I have already prepared the code. Instead of typing it just to save the time, I'll just paste it here. Actually, this is a very simple solution. We just have to calculate the absolute distance from the current position of the passenger to the current position of each taxi and see which one is the minimum after multiplying it with the time. So here I'll just explain step by step what we have done. I have done here. So if you can see this entire code, so here in this entire code defines a function minimum time that takes 4 input parameter, that is n, that is number of taxis, current is the current position of the passenger, position is an array of length n containing the position of the taxis, and time an array of length n containing the time taken by each taxi to cover 1 unit of distance. Then we initialize a variable called min time to maximum possible integer value. Then we iterate over all the taxis using a loop that runs from 0 to n minus 1 here. Then calculate the distance between the current position and the ith taxi using math.absolute of position I minus current. So we have to calculate the absolute distance here. Absolute distance will give you always the positive number. So either from the right side or the left side, the taxi will come to the current position of the passenger. So that's why this absolute distance is coming. So we will get the distance from here. Then calculate the time taken by the ith taxi to reach the current position by multiplying the distance with the time taken by the ith taxi to cover 1 unit of distance, that is time of I. So whatever the distance we have got here, that will multiply with time of I. This will represent the time taken by the taxi to cover 1 unit of distance, taxi I. Okay, then update the min time variable with the minimum of the current min and the time taken by the ith taxi. So whatever is the value we have till now, so this one, whatever was the value, and this time we will compare that which one is the minimum, and whatever the minimum will get, we will update to this minimum, and once all the iteration is done, then we return the minimum value, this one, then return the min time variable, this value. And suppose if there are no taxi near the passenger's current position, then the function will return integer of max value that we have initially set. Suppose if this n does not containing any input here or no taxi is present, so simply whatever is the value we have initialized, that only will return. That's it. It is that easy code, and this much is only the code and explanation for this problem. Now let's try compiling this code. So here you can see we have got correct output. Let's try submitting the solution. So here we can see that all the test cases have been passed, and this problem has been solved successfully. So talking about the time complexity of this solution, so this is in the order of big O of n, where n is the number of taxis near the current position. This is because we iterate through all the taxis to calculate the time required to reach each of them. The time taken to calculate the distance and the total time for each taxi is constant, so it does not contribute anything to time complexity. Okay, so I hope even this is clear. Yeah, so I'll provide the link for this question in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.